This is a new example. This one is about activity tables, tables that measure the activities that are being performed, are tested and performed by either uh, an entire, let's call it a plant essential oil. So that by the name of the plant, we'll know that, or the individual chemical components or constituents that are in that oil and what it's being tested on. In this case, for instance, here we have it being tested on different kinds of bacteria. Okay, so we're trying to figure out the minimum inhibitory concentration, MIC, of this particular essential oil from these two plants against these 10 tested bacterial strains. So as you can see, we have the same types of problems we have in the simpler chemical constituent tables, sometimes having more than one column heading. Sometimes maybe there'll be some sort of result at the bottom that's summary or something different. But in here we have other issues. So for instance, so this is source. It might be named differently from in other things. Here we have cells. Here they're testing the IC50 value. This is what toxicity or what percentage of that 50% of the bacteria or whatever being tested, or cells in this case, will die uh, uh, of using that particular oil. Here we have again not only two column heading rows, but you can see that there's 3 for each plant, right? So how do we split that out? And in fact, what would be preferable is to have this table split into one for each plant, separate tables, one measuring S. officinalis, one measuring M, whatever that is, and the other one. There are other tables that are even worse, you can call it that. So for instance, this one, it goes the other way around. Each row gets its own plant rather than each column. So this table really needs to be rotated 90 degrees for this to make any sense, according to the tidy tables standards, which I'll include a PDF in the Dropbox so you can see what I'm talking about there. Species, family, methods, all of these things need to be normalized and output into another table where in that table, each row always has the same kind of data in the same order, regardless of where it came from. So this is very challenging, obviously. Yeah, and then there's the way that these results are measured. Well, here we go, 3 different measurements or more on different rows. How do we normalize that? It's really bad table creation on the author's part. But I guess they're not trained to create tables. They're trained to do experiments. So here's some examples, as I said before, provided before. There you go. In this case, we have the PDF we can download. We also have this free full text that opens this area up here. When the free full text opens up, you can see the entire article and the tables. And as I mentioned, see, these tables are in HTML, but they can be opened in a separate window. Unfortunately, the URL for these is not something you can predict rather. It's different for each paper. So that means you'd have to detect it if possible from the code, the HTML code or CSS or whatever it may be, because that's not my department. I hope all of this makes sense, and I hope that this stimulates a conversation of some people who are looking for a really, really important and tough challenge, because this would change the lives of scientists and researchers all over the world. And I hope that you'll contribute to it. Thanks very much for your time.